to the webinar. Today we're going to see what's new in SolidCAM 2019 in the simultaneous 5-axis area. My name is Amod Omkar and I'm the product manager for SolidCAM 5-axis. So in this webinar, I'm going to show you a few of the features that we introduced in 2019 version of SolidCAM in the 5-axis area. We have made some significant changes to the software in 2019. We've improved quite a lot of features. We've added some features into it. I'm going to start off with the short features that we introduced in 2019. The first one was a feature that we introduced was the gradual front shift. In this particular feature, what we've done is we've basically allowed the user to define the front and the front shift from a front position to the back position. So we have added the front shift from and to values. This allows the tool to use the entire area of the tool, the face of the tool you can use over a surface. For example, the surface that you are seeing in front of your screen on this slide, you can see that if I had not used the front shift, the contact point of the tool would always be in the center irrespective of where it was cutting. By using the front shift, I'm moving the contact point of the tool from the front when it is in contact with the job for the first time, and when it leaves the job, it basically ends up at the back of the tool. So we use the entire contact area of the tool over the surface. The application for this particular feature would be, let's say you would like to use a polishing wheel and you would like to polish the surface in 5-axis, and you would like to use the entire surface of the wheel and not allow it to wear out only in one portion of the area. You would like to use the entire face. In that case, you use this function of front shift. Another feature that we added was to allow you to apply different feed rates when you're doing leads and links. Even when it's the gap and when you're linking between two slices in 5-axis, you can apply a different feed rate. In many cases, the links are a non-cutting motion. So you would like to move those motions very quickly. So you would like to apply a different feed rate than what you have used for the cutting feed rate. So here now we are allowing you to apply these new feed rates into leads and links, basically on slices as well as when it is going through the gaps. Another very important feature that we introduced was to smoothen the toolpath. We have the option of corner rounding, and the corner rounding works very well when you have a single pass, but when you have a multiple passes and you would like to round off a corner, we have now introduced a feature to smoothen out this area. We use the smoothing toolpath where we define the smoothing distance and the detection angle, and based on this, you can see on the right hand side it starts smoothing out all the passes that are there in the toolpath wherever it finds the area falling within the given ambit of the parameters. Okay, so let's look at some of the features like what I've talked about. Let me open a file. So we have a file out here with the surface. In the first instance, what we will do is in the tool axis control, I will switch off the front shift and keep only the front shift from. We will not allow the second one. We will just see what is the result we get if we just use the front shift without the two options. Okay, let's calculate. Now if I simulate this, let's go into the front view. Okay, you can see that the contact point of the tool is always on the front. So as I move over this job, the contact point will never change. It will always be the front of the tool that will always be in touch with the part. Okay, and as it comes down to the other part of the surface, you can see that it will just stop the moment the front touches the tip, and it will change its orientation in such a way that it now will make the backside, because it's now traversing backwards, because it's a zigzag toolpath, it will now make the backside in contact, because that becomes the front now. So it will keep that point in contact and keep moving ahead. Now, if I change this and say from 50 to minus 50, you'll see what happens now. Let's simulate this toolpath. Let's run. You can see the first contact point is in the front, but you will see that the contact point will keep changing. It will keep changing, and when it comes to the center, the contact point is the center of the tool. And as it moves and goes towards the end, the contact point has already moved from front to back. So we have shifted the contact point from front to back using this function. So like I said, the application could be as a simple application like polishing in 5-axis, where you would like to use the entire surface of the tool to be rubbing against the surface that you intend to polish. All right, so let's look at the other feature. Let's open another file. On the smoothing. Okay, so here we have a toolpath which does not have the smoothing but only has a corner rounding. So in corner rounding, you can see that only the last pass is rounded up, whereas the other passes are still having a sharp motion. By switching on the corner rounding option or the smooth option in toolpath parameters into modify, we switch on the tool smoothing option. When this is switched on, my result is completely different. You can see that, my entire toolpath, whenever it is having a sharp corner, gets smoothed up. So you get a nice rounding, and the tool moves around that area pretty smoothly. So these were some of the little things that we announced inside SolidCAM 2019. Apart from that, we introduced a completely new strategy, and that's called as a multi-axis constant strategy. And this particular multi-axis constant step over, this particular strategy allows you to define a fixed pattern over several groups of surfaces, either it's surfaces or meshes. It defines a unique pattern on the mesh and also on the surface, and generates these patterns in such a way that it provides a constant step over even on really complex areas of the part. So with multi-axis constant step over toolpath engine, SolidCAM now provides the next evolution in the field of pattern generation. It's basically a pattern generator. So it generates the pattern using a global distance field without a fixed direction as a reference, meaning that when SolidCAM used to develop the patterns before the constant step over pattern was introduced, the tool axis direction was very important. Based on the tool axis direction, the patterns used to get generated. But now we use a global distance field. So if I say my distance between two patterns is 0.5 millimeter, then it will generate 0.5 millimeter no matter where the pattern is being generated. It doesn't use the tool axis as a reference. It just generates a pattern on it and then converts the tool into toolpath, applies the tool axis direction. It works very well on mesh data and also on group of surfaces. So you can have a group of thousands of surfaces, or you could just provide a mesh data to SolidCAM, or it could be just a simple solid model. In an undercut situation, which is related to the fixed direction, for example, in this area here, you have, in this area here, you have got a pretty nice undercut relative to the Z direction that we have here. So even in this area, SolidCAM, you can look here, generates a very nice pattern. So this entire toolpath is a single toolpath in 5-axis. We just have provided the entire group of surfaces to it, or the entire model, solid model as it is, and it has generated a very nice pattern to machine the entire part. Right. Another example is of an undercut situation where you have parts like what you see on the screen, and these kind of parts coupled with automatic tilting, it gives a very consistent and reliable result. The pattern is very consistent. If you say 0.5, it will be 0.5 throughout the entire group of parts, group of surfaces. Right, so let's have a look at the pattern generator. So let me open a file. Okay, so I've got a pretty small part here, and what I have in my first group is a group of surfaces, right? So we have a group of surfaces, and I would like to machine this group of surface parallel to this particular curve. Okay, I would like to go parallel to that curve and machine this entire group of surfaces 5 axes. My tool axis direction is defined by these 8 lines. So my tool axis direction will be along these 2 lines. These 8 lines will define my tool axis direction. Okay, so if I look at the pattern generator on the parameters, I'm using a scallop of 8 microns, which it converts the step over to 0.506. So that's the step over. And the result, what we get in this particular example is this. You can see that it has generated a very nice pattern, basically following the 8 lines. So if I run the simulation slowly, you can see that it's using a nice 8 lines that I've defined, and based on those lines, it is now machining the entire group of surfaces that I defined and going parallel to the curve. So it doesn't matter where it is machining, it will always be 0.506 between 2 generated slices. So it will always have constant step over in 5 axes. Okay? Now, a slightly more difficult situation would be in the same part, but instead of defining surfaces, what I've done is I've defined the model as it is, solid as it is. Okay? And here I have basically 2 contours. I've got the outer contour and the inner contour. So now I'm going to do a morph kind of a toolpath between these 2 curves. I'm using the same curve 8 lines as the tool axis guiding lines, and the result that I get over here. Okay, you can see that the pattern generator did exactly the same thing what it did before. It generated a constant step over irrespective of where it's cutting. It doesn't matter. And the end result is smooth toolpath, giving you excellent surface quality over a group of surface or also over a mesh. Another part we can have a look at is this particular part. The undercut part that I talked about. Okay, so here, if you look, I have defined just the group of surfaces that I would like to machine. I've said that I just want to machine these surfaces. I did not define what curve it needs to be parallel or between what 2 curves it needs to morph. Because the pattern generator is smart enough that even if I don't define any curves to machine it, it understands that I've defined an open kind of a geometry, and it tries to find out the best possible combination of curves to which it needs to be parallel or to which it can morph. So I've just defined the tool and the group of surfaces, and also my tilting direction. I've defined that. My tool is basically a lollipop tool. You can see here, this is a lollipop tool, and I've used the auto tilting mechanism in this. The auto tilting is a highly reliable mechanism that can do very good gouge checks, can be very reliable in terms of gouge checks, and the result is a straightforward toolpath that can be directly taken to the machine. So the end result in this case is that if I run the simulation, you can see that the pattern generator again is behaving exactly the same way that I wanted it. It's generating constant step over and machining the part. The tilting is taken care of by the tilt direction. I just defined a curve. You can see that it's now machining the entire part. And as the tool goes inside, the auto gouge check comes in, the auto tilting comes in, and it takes care of the gouge collision checks between tool and the surface, or even the holder and the surface. Okay, so it's pretty nice. Generates extremely high quality of surface finish because it's using extremely consistent spacing between two strands of the toolpath. And on top of that, we have the auto tilt in the gouge check, and that takes care of collisions between the tool, the geometry, the holder, and the other areas that are involved into this. Okay, so that's how it does the parts like this. We'll see another group of part or another part where it's even more nicer. Okay, in this case, I have defined a group of surfaces. Except the bottom, I've defined everything. And what I've defined here is the curve to which it needs to be parallel. The cuts needs to be parallel. So what it has done basically is, you can see that it generates a pattern which is parallel to the entire geometry. So let's take a slice of the part. Now I've sliced the model, taken a section. I have a section at the front, and if I switch on the toolpath, you can see that it's encompassing the entire part. So I've used also auto tilt in the gouge check. Okay, let's switch on this. Let it come up so I can show you the gap that comes up when it gets really tantalizingly close to the part. Okay. Okay, now this should be pretty nice. You can see here, it's generating a gap 0.5 millimeter, which I have kept as the distance between the arbor and the part when it's doing the gouge check. Okay, and as it starts moving up, it even gets even more interesting. So here, it's still maintaining the 0.5 millimeter gap between the arbor and the part. And as it goes up, it's doing the same thing. It's just a single tool path. There are no multiple tool paths in it. Single tool path machining the entire thing. Consistent step over even over the fillets. And as it goes inside, it again generates the same consistent pattern all the way down into the part. For those people who are using SolidCAM, for those customers who are using SolidCAM generic 5-axis of morph between two curves and parallel to curves, for them, the multi-axis constant step over can be really a big quantum jump in terms of both the handling of difficult surfaces and also getting very consistent tool path with exact spacing between the two strands of the tool path. So for customers who are already using morph between two curves and parallel to curves in their paths can actually migrate to this engine and move all your tool paths to this particular tool path generator. Okay, so this was a bit about the multi-axis constant step over. What we can do now is move to another very important topic in 2019 was the circle end mill support. SolidCAM in 2019 supports the most commonly used circle end mills. Okay. Now, what are basically circle end mills? Circle end mills, more and more tool manufacturers are introducing them because what they are claiming, tool manufacturers are claiming is that it can reduce up to 90% in machining time when you
Để
use
gọn cái này vào.
And we have introduced the SolidCAM, we have
Không bật điều hòa nhé.
introduced the support for the common circle end mills in 2019, and we are the circle shape.
Ông phải cho tăng độ lên nha.
And lens shape. Now we also have got some special tilting mechanism which I'm going to come next to. These tools, when used in conjunction with the right tilting, can actually reduce your cutting time.
Ông ơi, bài tính của bố
They have
cháu.
got a very large radius on the side, and this allows you to take a large step over, as shown here. So if I compare
Ông phải bật
diameter 16
chú khác đấy. Không phải
the
bật
diameter
bật chú
16
ba đâu.
oval form tool which has outer radius of R90, you can see that for caliber of 0.46 micron, the circle end mills, the old form will take a step over of 1.5, and for a scallop 3 times smaller than that, it has to take a step over of 0.5 millimeter here. So you actually end up reducing
Máy tính của bố con đấy.
Ông ơi, con cháu được không? Không phải vỗ tay của bố cháu.
the much smooth scallop
Chơi đi.
using circle end.
Ngồi đây.
So that's how
Ngồi đây chơi. Đấy, nhiều lắm. Nhiều đồ chơi đó.
one of the reasons why circle end mills are used, and
Ô tô đâu?
advantages over
Ơi.
end mills is that when you're using, let's say, when you have a
Ô tô này.
surface like what's shown here, when you have a straight surface like this and you're trying to use an end mill, up to a certain value of the end mill length, the tool behaves very nicely. But after that,
Nhiều quá.
the deflection starts. And when the deflection starts acting, you can start getting surface. If you actually move your finger on the surface, you feel this scallop. But on the other hand, if you're using a
Em ăn
barrel,
không?
the barrel tool
Em ăn
also
chưa?
has got similar
Không muốn
deflection.
tay nhá.
But because of this radius out here, the deflections are minimized, or they are balanced out, and the scallop that you started off in the beginning is maintained all throughout
Cho chị nghe đi.
get a much better quality of the surface, even though you're introducing vibrations into the cut. It's being taken care by the geometry of the cut. So you have got lower dynamic difference.
Đây đây.
Short
Kia kẹo kia.
the barrel tool,
Yeah.
you need not even cut straight. You can even tilt tool at an angle alpha,
Đây mà
and
coi
it
này
will
này.
still be in touch with the radius.
Đâu rồi? Đây rồi.
Consistent scallop that you would
Chọn
get
một.
when you go straight. Okay. Circle end mills are also used when you get into a situation where you're
Ông phải cho tăng độ
and you
lên.
cannot use your
Tôi tăng rồi.
get or you have to move the ball by tilting the tool. But again, when you tilt the
Cho
ball,
rồi.
you know that you cannot give
Đâu?
a bigger step over to achieve a smaller scallop. You need to go with a very small step down.
Thôi được rồi, để lên.
But with a barrel mill, I can easily tilt the tool, still take larger cuts, and achieve a much smaller scallop. Some of the barrel tools, like oval form tools, have got dual radius, one radius, and one on the flank that is a pretty large radius. The one on the tip is more radius,
Nó đừng sờ đấy.
fillet on the side wall or on the bottom. So the oval form kind of tools have got dual uses. They can either
Đánh
be
răng,
used
em bé đánh
to
răng.
machine the flank of the surface, or you can use the
Ôi,
tip of
đừng,
the
đừng.
tool to fillets and other
Ôi đôi xe
you
đâu.
cannot get in. So
Ăn nữa à?
dual use.
À.
Now, as we know that not everywhere you can use circle end mills, there are certain situations where circle end mills or barrel tools. Situations is when you have a surface with convex shape off the bottom feed direction.
Em đỏ
Here,
mắt.
you should always use end mills on its flank. Step over
Ôi,
is
đừng
anywhere
ngã.
limited to the part geometry, so you cannot take a bigger step forward with a barrel and mill, so you don't have to worry about the mass between them. You are anyway going to take a small step over.
Cộng mãi
The
em.
other situation where you cannot use barrel
Ngồi dậy.
basically surface with
Ngồi dậy.
radius smaller than the barrel radius. Anyway,
Ngồi ngay dậy.
you cannot reach into this area, so you cannot use circle tools. You cannot use barrel tools or you cannot use old form tools on 3-axis machines because it doesn't make any sense. You will still not get the desired.
Không cho mông bẩn.
Okay, so in that case, you cannot use a circle angle. You need to do either a bull nose or a ball nose ender to achieve the scallop. The other challenge that we have with the barrel, now these are the challenges. This is not the implementation of the barrel ender.
Nhé.
Coming from the software side.
Xuống dưới này.
Process
Lúc này ngồi ai mà ngồi dẫm lên.
certain profiles on these nice looking surfaces on which you like to
Xuống
do
đây.
the barrel surface. So here the scallop calculation becomes difficult because you have a big surface and then some very arbitrary shape inside there. You cannot go with the same bigger scallop. You need to have much finer scallop. Now we are working on this.
Giải chiếu ra.
And we should be able to address this challenge.
Đúng rồi, ngoan rồi. Đấy em bé ngoan
Another
lắm, giỏi
challenge
lắm.
is that when you're working with an oval form,
Ra đây.
the tip of the tool is actually very weak.
Những muối
So
xúc
if
miệng
you
đấy.
start
Ra đây đừng.
pushing the flag and go down or into the floor and the
Đấy yên ở đấy nhá.
the tip gets extremely high
Đừng nghịch nhá.
and that can wear out the tool very quickly. So in this case,
Con để vào
it's
túi.
always
Đúng rồi.
imperative to machine the floor first and then go and machine the flag.
Con để vào lọ,
Again,
để
this
lọ vào túi.
particular
Để lọ thuốc vào túi
challenge
đi.
is being addressed by
Đúng rồi.
we should have some kind of solution on this. When it comes to tilting using barrel end mills, SolidCAM has made quite a lot of changes and introduced some very nice functionalities for tilting. In tilting, we have introduced, apart from angles, we have introduced contact point tilting.
Ôi.
Contact point tilting is works with both ball nose as well as all the barrel tools, in which we can define the
Bỏ
contact
ra.
point as a static contact point or a dynamic contact point, which is always moving. In a static contact
Cất
point,
đi, cất
I can
cất lọ
define
thuốc vào
the
trong túi.
tip of the tool.
Sao cất lọ thuốc vào túi đi nhá.
Okay.
Con nhá. Đúng rồi, cho thuốc vào túi đi. Đấy, đúng rồi, ngoan đó.
Tip of the tool. What is the
Con để đấy để
distance where I want
cho
the
mẹ con rửa
contact
cho
point
chị
to be?
nhá. Ừ, con để đấy.
Không có thế không
Con cất xuống đây.
Contact
Đưa
point
ông cất cho.
to the tool to the required angle.
Ngồi nhanh.
Okay. Another way is to say I don't want the distance of the tip, but I would like
Là đưa
a
ông cất
certain
nào. Nhá.
percentage over the
Đưa
barrel
ông cất cho
profile. So
con
I
nào.
can say
Đưa ông rửa
maintain the
đó.
contact point at
Ông cất đấy
30%
nhá.
of profile.
Alo đi. Xuống đây alo.
Again, it will determine what is the contact point, and it will keep tilting the tool in order to maintain that contact
Đúng rồi.
point always on.
Sao ơi. Đây.
Another option is
Ông đã
dynamic
cũng em
tilting,
cần
used
dùng
more and
cái
more by
Ừ, xuống đây tập thể dục với
we
chị.
start with a particular
Ờ.
contact point. Let's say we start at
Xuống đây tập thể dục
50%
với chị.
of the tool, and we say my end result
Ôi
is
giời ơi,
10%.
ok. Đi xuống đây mà.
Find out the
Con gái, kêu mất em xuống đây.
based
Mấy
on the
em
plan
đây.
on the flag, it distributes the
Yêu
point.
cho em tụt xuống. Nào, xuống tập
And
thể
the
dục
tool
dưới này.
then calculates the tilt angle
Ừ.
for
Nào,
each
để
of
tập thể
the
dục đi.
path of the tool path. The tilt
À,
angle
đây này.
change
Sao ơi
the
này.
contact point.
Sao ơi này. Chị nghe tập thể dục
You
này.
start off with contact point.
Nào, đứng dậy tập.
You end
Nào, đứng dậy,
last one with
đứng
the
dậy.
contact point.
Đứng dậy tập đi.
This is what
Ok, đứng dậy tập thể dục như nào?
dynamic
Ok, nghe.
dynamic contact point.
Đứng dậy tập thể dục cho em bắt chiếc đi.
Over the
Kìa.
profile
Sao lại đưa
start
chị
with
vào
the
chị
end
tập
of
thể
the
dục rồi?
point.
Đấy.
Okay,
Chị tập thể dục khỏe không nhỉ?
let's look at
Chị tập thể dục đấy.
all the files for circle
Tập
and
thể dục này.
how we handle
Chị tập thể dục đấy. Đấy.
quá rồi.
Mệt quá nghỉ.
it apart.
Phải làm.
Cứ làm
So I've got a pretty deep part here, and
Ôi ra đây đừng
I
đừng
know
đừng.
that I cannot
Không không nghịch vào của bố con ấy.
section. I know that I cannot use
Cái
an
tường
angle
ơi.
because if I look at
bị
the
rơi rồi.
Hả?
distance, it's
Cái
about
này em
125
ở lên
mm.
rồi.
Ừ
An
thôi
angle
thôi.
of
Tránh ra.
125 mm
Kia
machine.
kia
But
bố
if I use a
bố em bố
ball,
thì ngại.
I need to tilt it and I'm limited by the radius of the tool, and I cannot give bigger depth of cuts. But
Ôi, tập thể dục này.
address
Sao chị nghe tập thể dục?
so I have here
Tập thể dục.
the oval form tool.
Tập thể dục đấy. Tập thể dục. Giỏi nhá.
16
Ngoan nhá. Chị
with
tập thể dục
a
này.
large radius of 75 and the 10 radius.
Chị nghe tập thể dục đấy. Con tập đi. Con tập đi.
We're using only 55 millimeter out of the whole.
Alo.
An LYD ratio of less than 4.
Alo, chị nghe tập khỏe lắm. Chị nghe
And
tập
what
khỏe
I
lắm.
have here,
Chị nghe tập thể dục giỏi lắm.
let's get the entire part here. So I've got the geometry here. That's the surface.
Ôi trời ngon
And
quá.
I've got the two
Ngon
curves
quá,
here,
giống như ông ngon quá.
which I'm going to be morphing
Ông ơi,
by
nhìn con này.
passes.
Ừ, đấy con tập thể dục. Sóc tập thể dục giống chị đi. Thể dục.
And the tool is control what I've done here.
Đấy, đấy, chị tập thể dục.
For those of you who are
Đấy, sóc tập thể dục đấy.
2019,
Ôi, khẽ thôi, đau chân.
slightly new.
Đừng đạp trên đau chân.
All our side tilt definitions to a completely another tab, because now we are getting part of it, we are getting contact point tilting options also. So here I have used the contact point tilting options. Like I said, we have two options, by height and by line parameter. When I say height, it calculates the height from the
Vứt đi.
tilt along the z direction or
Cất đâu đi.
when I use the line
Thôi đừng
it
con cất ở đâu
calculates
đi.
along the
Cất
parallel
vào cái
profile
chén.
or the curve profile.
Ôi, chèn nữa.
So here
Cất
I've
vào.
said that it should start the contact point at 50% of the group length.
À,
And
hai
contact
người
point
mình giống
should
rồi.
stop at 10%.
Ừ, nhiều đồ chơi thế.
Lắc hơi.
À, kìa, chị nhảy đi này.
Ơi, lắc.
Nhảy giống chị đi. Sao nhảy giống chị đi? Ôi, nhảy giống chị này.
Making the first contact.
Nhảy giống chị đi.
And as it goes
Nhảy
down,
qua giải lao.
between one pass, second pass, third pass,
Giải lao.
and as it goes down, you can see that going down, you can see that changing the contact point and
Bỏ áo của mẹ con
as
vào.
it comes down
Bỏ
towards
áo của
the
con
end,
vào giường.
shifting its
Cái phần này.
closer to the 10%. You can see
Dạ đấy.
the
Mày vỡ được của bố mày chết cha mày. Mẹ ơi. Nhảy thế nào thế?
What it has done very nicely is machine it till the end, and that's it. So you can use now a barrel tool with a dynamic shift contact point and machine the surface. Don't worry about the tilt angle, because the tilt angle
Thôi
will be
ấy
calculated
không đổ
by
vỡ của
software
máy
as
tính của bố còn chết.
over the surface.
Đứng ra đằng này. Nhảy. Đi.
Now, like I told you,
Ra đằng
we
này.
have got,
Nhé.
we've used an oval form,
Cái
so
không
we
ấy đây
can
đổ máy tính của bố còn chết.
dual uses to this oval form tool. The flank was used to machine the surface.
Tí nữa thì đổ
The tip
vỡ máy tính.
was used to machine. We can use the tip to
Đi ra đây,
machine
ra
the
đây.
fillet.
Ra đây
And
không
also,
không không ấy vào đây bố con hỏng máy tính của bố con nhé.
so you can see that the circle end mills are actually going to revolutionize the way you cut 5 axis. They're going to reduce your time of cutting because they have got a very large radius.
Ra chỗ này nhảy ở chỗ này.
Bigger depth of cut,
Yeah.
yet generate very
Nhảy
small
đấy thì
scale.
nằm hỏng máy
So
tính của bố
your
con
cutting
chết.
time
Đi
can
ra đây
really
nhảy.
come down. So these were some of the very nice features that we get
Chưa vỡ,
outside
chưa vỡ.
for solid.
Đi ra đây không vỡ.
If there are any questions, I would like to answer them. I already see that
Còn đâu
question
bây giờ?
here.
Còn đâu mày làm đổ nó
Is
vỡ
there an
thật.
operation within
Nằm
is
cành
there
xuống
an
đấy
operation
tí giải
within
lao đi.
5-axis module which automatically generates Mac position to the machine? Okay, this question comes from Dave Powell. Dave, thank you very much for the question. I think we should have
bị
this
vỡ chân.
operation pretty soon inside SolidCAM. We're working on it,
Không phải
and it
không
should
phải
be
đồ đạc
inside
không vỡ
SolidCAM.
đâu. Được chơi không vỡ.
There's another question on how to extend the constant step over toolpath at the beginning and to the end. If you look at the constant step over here, this one, sorry, let's add. If I go on to surface selection and go into the toolpath parameters, I have an option to extend this sidewards and also extend it tangentially. But the whole thing is here that you cannot use a closed mesh to extend the toolpath. Your geometry has to be a group of several surfaces. It could be thousands of surfaces. You can select using color or any other method. And once you select these group of surfaces, create an open mesh, and there the toolpath can be automatically extended by any value that you want. I think that's it. I don't see any more questions in this. Maybe there's one more.
Cành nhé. Cành hay dược. Thế ra chỗ này nhảy đi con.
Somebody asked for the PowerPoint presentation. I'll just check if we can give this PowerPoint presentation. In the event we can give it, then it will be on our website, and you will have the presentation in our on our website. You can actually download that. It should have some of the features that I told. Sydney, I'm done with
Yes, that is available on the website. This webinar that we've done with this.
Okay.
Go to the to our website under what's the webinar. You'll be able to see together with the webinar an option to download the presentation as well. Okay, Amo, thank you very much for the webinar. I hope everyone enjoyed it and gets a lot of use out of this. So they know it's a major improvement to what we've had before. And we'll see you again in our next webinar. So everyone take care and have a great weekend.
Thank you. Bye-bye.